we have this limit question. We want to get the limit of this polynomial as x approaches 2. And generally speaking, when you're dealing with polynomials and limits, what you see is very straightforward, because polynomials are usually they are a continuous function. So in this case, we just do a direct substitution. So this becomes 2 squared minus 2 times 2 plus 7. And the answer in this case will end up being 7. Okay, simple as that. Now, there are cases where the direct substitution does not work. That means if you're dealing with other type of functions, for example, you're dealing with rational functions, trigonometric rational functions, you could be reciprocal functions, which is rational functions part of that. Reciprocal function is part of rational functions, or square root functions, or any other functions that you could have a discontinuity, or you could have a discontinuous function. So let's look at this question right here. And this question says, find the limit as x approaches 0 of 1 plus x to the power of 4 all minus 1 to the 4th all over x. So we want to go through and take the calculate the limit of this rational function. Notice that if you just substitute 0 for x, this may not be, and in this case will not be, a correct answer for the limit. So you have to actually simplify this first, and we're going to use a binomial expansion on this one. So you can actually just go through and do the 1 plus x all to the power of 4, expand that, and you'll get 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. And then we're going to close the bracket, subtract 1, because 1 to the 4th is 1, all over x. When we do this, we can simplify it. 4x case. Sorry. All right, so now we can easily factor the GCF out from the top. What we will have is x, you're going to factor that out, you get 4 plus 6x plus 4x squared plus x cubed. All of that over x, and notice that x divided by x. Now the simplified form we will have is this: limit at x approaches 0 of 4 plus 6x plus 4x squared plus x cubed. Now when we do the substitution, notice that the answer will end up being, in here will be, this would be 0, this would be 0, and so that would be 0. So we have limit as it approaches 0 of 4, and that will end up being 4. So this was a case of dealing with a rational function, possibly, that has a discontinuity, but the limit does exist, and the limit at x as x approaches 0 is 4, but there is a discontinuity happens at 0. Okay, that's basically the two questions I wanted to go over.